I just give you some the basics about the fundamentals of the data warehousing. Okay, what is data warehousing? Okay, this is very much important because we are part of the Power Query editor. Look here, this is what your data warehouse. For example, this is your data warehouse. Here's something else called OLTP system. Okay, OLTP. This is also called as OLAP. Different people use different terms. Okay, so OLAP stands for online analytical processing. Analytical processing. Either they use the term OLAP or data warehouse, but this is the commonly used term. Okay, most popular term. And this is my source system. Is OLTP. Okay, and okay. So here you have the database. Listen, you have the OLTP database. Okay, this one may be your SQL Server or Oracle. So here you have the customer table. Listen, you have the customer table, customer master table, and then customer address, something like address table, and orders table, orders master table, sorry, orders transaction table, and orders master table. So, okay, sorry, this is your transaction table. This is your master table, transaction table, master table. And there are some cases, right? You have the something else called product master table. Master table is nothing but lookup table. Okay. Likewise, all the tables are there here, and you have orders table. So what happens? You have the e-commerce app. Customers are ordering products in your company. Okay, they are using your e-commerce app and they are ordering the products. So whenever they raise any order or something like that, that data will get stored in these tables. Okay, the source system tables. Okay, these tables. So this source system contains the limited duration of data. So they call the term as a data retention period. Data retention period is very common, not only for, it is not applicable, it's not only applicable for source system, even data also. But in this case, the retention period is very limited, okay, the limited duration of data, okay. So maybe, right, they will have 2 years of recent 2 years of data, okay, in the case of e-commerce and only 2 years of data, because they don't store huge volume of data. The more the volume of the data you store here, it will slow down the performance. The whole idea of the OLTP databases, it should allow concurrency. Multiple users across the country should be able to order it simultaneously, or within the same country, multiple customers should raise the order concurrently, in the sense simultaneously. The performance should be, pretty faster, so only when you store less volume of data, less duration of data, just 2 years of data alone, if you store it, the multiple users can, even if multiple users can access database, the performance will be pretty fast. They can raise the order in a pretty fast manner. Let's say you have 10 years of data and you have 5 petabytes volume of data here. What will happen? You are raising an order with my company, and other person is also raising. It's, two customers, A and B, right? Since the volume of data is very high, right? It takes, he is looking at the product and he's doing a checkout. This guy is trying to do a checkup, but it takes longer time. He has to wait. It's hanging. What will happen? So, both guys are working guys, right? So what you will do, you will lose patience and you will go and order from some other site, your competitor's app. You are going to lose the customer. Okay. To improve customer experience also, right? What they do is they make sure that the source system OLTP database should provide concurrency. So in that case, they make sure that they keep less volume of data or less duration data in the OLTP database. Okay, fine. Let's say internally in your company, let's say you work for Walmart. Okay, Walmart, they have the app and customers are ordering the products, everything, using their e-commerce app, and in store also they are buying it. We are talking about e-commerce. Okay, fine. So internally, what Walmart top management, they want to understand which line items are we selling it more? Which region are we performing well? In which region, in which category are we really performing well? Which regions are underperforming for a specific category? To ask various business questions, to get the answers for their various business questions, they need to have a separate database that is called a data warehouse. Okay, this is not the software name or this is not the application. This is a concept. Okay, data warehouse is a term. Okay, it's a concept or it's a term. It's a terminology. Okay, term. Okay, so but in the case of data warehouse, right? So all the internal management, if they want to perform any analytics, right? So they do it, from with the help of the data warehouse. Okay, analytics they perform with the help of the data warehouse. So in the case of data warehouse, so see what for analytics purpose, to perform analytics, they need a separate database that is called data warehouse. For customers, right, to cater to the customer needs, there is separate, database that is called the OLTP. This is a transactional. This is called your transactional most of the time. This is, this is called aggregated. Most of the time, this will have aggregated information, aggregated data, and it consists of historical data. Historical data, and also it is non-volatile. The data, since I mentioned historical here, for example, you have 5 years of data you store here, historical, but whereas here maximum 2 years or 1 year only you store the data here. This is historical and it is non-volatile, and aggregate data, they store it here. And what is it? And time-based. Okay. Historical, non-volatile, time-based data it will have, and aggregate data it will be there. So here, 5 years, let's, it depends on the, industry, depends on the company. Okay. Let's assume that, in this case, the data retention period is to 5 years. Okay. Every once in 5 years, every new year comes, right? They will roll forward. Okay. That means, let's, you 2000, currently we are in 2024 and 23, 22, 21 and 20. Okay. This is 5 years. When 2025 comes, they roll forward. So this one, they will list a year, they remove it. They will maybe they archive it or delete the data. They keep the recent 5 years. The previous years, they will be removing it. Okay. This is called roll forward. Okay. So 5 years is the data retention. Historical. So data warehouse is nothing but, it kinds of historical data, and it's a non-volatile. Once you store the historical data, it will not be undergoing any changes here because the volume of data are very huge here because of because of the fact that you store the 5 years of data here, right? And if you make any changes to the 5 years of data, it literally slow down the performance. Okay, remember that in the case of database, it's a data warehouse or OLTP. If you make any changes, update, modify the data or delete the data, that's a very expensive operation because it requires a lot of memory, CPU, IO and all. Okay, hence what they did, okay, let's store each and every transaction here, okay, data here, and let's make sure that these data are not going to change. We are not going to make any. If you make any change or update, it will literally slow down. Okay. So it contains the detail as well as yes. It contains Supriya. Yes, it contains the detailed data and also it contains the aggregated data. Okay. Detail data and aggregated data also it contains here. Okay. And it is non-volatile. It will not undergo changes. Rarely it will undergo changes, and it consists of time-based data. What means, right? You store the data and time-based data so that you can perform like for like analysis. What is this year sales? and I want to compare current year sales with the last 2 years sales. I want to compare the current quarter sales, current year's current quarter sales with my previous 2 years current quarter sales. Like for like, so if you store the data, right, it's a time based, right? So it's a non-volatile, time based, and contains both detail as well as aggregated data and historical data. You have it in your data warehouse. So you have a dedicated database, which is nothing but a data warehouse to perform analytics. So that if you perform any analytics, right? So you want to apply some aggregations, you want to do some kind of sum and aggregation, average, all the sum, total, all the things against a huge volume of data, right? So since the data are stored separately here, right, what will happen? It will not cause any impact to the performance of the source system data, because you copied that what you are doing is on a daily basis or weekly basis, whatever the data comes in OLTP database, that you are pushing it to the data warehouse. For example, you started your business 10th June, 10th June, 11th June, 12th June, 13th June, 14th, 15th June, all the 5 days data will get stored here, accumulated here. All the 5 days data will get stored. Simply, it will push it here, okay? And similarly, right, 5 years data will get stored here. And so in this case, hypothetically, I consider, this data warehouse will contain 5 years. 5 years data it will have. So so not all the tables, right? There are some tables, right? They may not store it here. Certain, all the analytics related tables, right? What they do, they push the data as and when the new order comes, any new customer, they push it to the data warehouse tables. Here also you will have the tables like customer table or order fact, but here we use something called star schema design. Okay, here we have something called normalization. The table will be normal. That means, see, look here, the customer data itself stored in 2 different tables: customer master table, customer address table. So what we do is, when we store the customer data in data warehouse, we are going to have only one table called dim customer. So which means customer dimension. You might be asking this one, when you read it, you are saying that customer dimension, then why you put dim customer? This is the naming standard, commonly used naming standard, okay? Customer. But here, both the table data, they get stored. This is called denormalization. So this is called normalization. The data warehouse will contain the denormalized data in it. Denormalized data. Combining more than one table, right? Logically combining more than one table into a single table called your denormalization. This is denormalization, okay? Denormalized. The data will get normalized. So the OLTP database, you have normalized data and it is volatile. Volatile. So the data will get changed. Somebody cancels the order. Somebody modifies the quantity, right? That one gone. But here, right, everything will be there. Okay, before modifying the quantity, after modifying the quantity, before cancel, after cancel, right? All the data will be there here, so that they won't do extensive analysis. How many items ordered, how many items cancelled by the customer, which products cancelled more frequently, which products returned more frequently. So all analytics. So if you have the same data available here also, but that too, the historical data available here, what will happen is they can do extensive data analysis here. If they do any analysis on this database, right, it will not cause any impact on this database. You are not going to cause any disturbance to this database, right? But for the data warehouse, the sources coming from this source system only. Okay. But every day you have some ETL jobs, extraction process that will extract the data from here, and then on a daily basis load it here. But in the data warehouse itself, we have something else called staging area that we'll discuss it later. But I don't want to discuss so many things in the one session. You will be overrun. Okay. So with this, I'm going to wrap up, guys, because I have mix of people. What you do is, without fail, tomorrow morning, or at least later tonight, you can watch this video, especially